Talking about today? Well, today, my lucky tuning in people, we are going over carbon structures for your A-level chemistry exam. And we're talking about things like graphite and graphene and maybe some diamonds. Ooh, who knows? So let's dive into carbon. Now, we're going to be talking a lot about allotropes in this episode. An allotrope is just a different form of an element when the atoms are arranged differently. So we're going to start with diamond. Maybe I'll get one day. Who knows? Fingers crossed. And in diamond, each carbon atom is bonded to 4 other carbon atoms by strong covalent bonds. And this creates a giant covalent structure. Now, because there are so many covalent bonds in diamond, it makes it really hard because covalent bonds are very strong. And because diamond is hard, it is used as a cutting tool to cut other materials, which, honey, I think is a waste of diamonds. Like, put them on my neck. Like, don't put them in no cutting tools. But I guess we also need cutting tools, so whatever. Now, because of these covalent bonds, diamonds do not conduct electricity. None of those electrons are delocalized. Remember, a covalent bond is just a shared pair of electrons. If that's news to you, make sure you check out the covalent bonding episode in this series to get up to speed. But because of the lack of delocalized electrons, diamonds, they don't conduct electricity. They also have a very high melting point because a lot of energy is required to break those strong covalent bonds. So you could put your diamonds in the oven and they would be fine. Wouldn't recommend it, and it would probably wouldn't be the best idea, but they wouldn't melt, so that's fun. And finally, diamonds have a very rigid structure, and this means the vibrations can easily carry heat throughout the structure. So diamond is an excellent thermal conductor. So they'll be very hot when you take them out of the oven, but they won't melt. So let's review some properties of diamonds. I want 4. Can you think of 4 important properties of diamonds? They do not conduct electricity. They contain covalent bonds. They have a high melting point, and they're very hard. Okay, so to recap the structure of diamond, a diamond is an allotrope, which is just a form of carbon. Each carbon atom in diamond is bonded to 4 other carbon atoms by strong covalent bonds. And this creates a giant covalent structure. Now, next we need to go on to talk about graphite, which is a different allotrope of carbon. And graphite has the following properties. Again, we've got some covalent bond action going on up here. Each carbon atom in graphite is bonded to 3 other carbon atoms. That's 1, 2, 3 other carbon atoms. And this creates a giant covalent structure. So again, both graphite and diamond are giant covalent structures. Now, due to the strong covalent bonds within these sheets, graphite has a high melting point and is insoluble in solvents. So remember, when you've got lots of covalent bonds, anything is going to have a high melting point. But graphite, unlike diamond, is soft. And this is because the carbon atoms form layers of hexagonal 6-sided rings. And each layer is held together by weak intermolecular forces. So the layers can slide over each other easily, so graphite is very soft. This makes graphite useful as a lubricant, as well as for use it in pencil. So pencil lead in inverted commas, is actually graphite, which is good because lead is not good for you. Also, graphite conducts electricity. Now, if you remember, each of those carbon atoms forms 3 covalent bonds. 1 electron from every carbon atom in graphite is delocalized. This electron can move freely, so graphite can conduct electricity. Stunning. So let's recap some of that. In graphite, the carbon atoms form layers of what kind of rings? They are hexagonal, they have 6 sides, and each layer is held together by weak intermolecular forces. And remember, those layers of hexagonal rings, they can slide over each other, which means graphite's really soft. However, the melting point, that's going to be high because a lot of energy is required to break those strong covalent bonds. Okay, that brings us to the end of this episode where we've been talking about different carbon structures and the different allotropes of carbon. So make sure you are happy with all those key definitions we've been over. And a really common exam question is to compare the structures of graphite and diamond and explain why they have different characteristics. So things to think about are the melting point, they're both high because of covalent bonds, electron conductivity. Graphite will because it has delocalized electrons. Diamond won't because it doesn't. Graphite is soft because the hexagonal layers are held together by weak intermolecular forces, so they can slide over each other, whereas diamond is really hard because we've got 4 covalent bonds between each carbon atom, so it gives it a really rigid, strong structure, so it can be used in cutting materials, for example. I hope that was a useful recap of carbon structures for your A-level chemistry exam. I've been Jono from Seneca. Well done for being proactive with your work and revision and doing all of that good stuff you should be doing. Keep up all your hard work, and I will join you in the next episode. Bye!